Hello everybody, welcome back to No Context Math for another fun example and fun problem. This is an interesting one. Can you solve the equation for x to the x cubed is equal to 729? If you want, feel free to pause the video, try to work this out, and then hopefully come back and see that both of us arrived at the same solution. So over here on line 1, the first thing you'll see that I did is just rewrite the equation and carry it over onto the new blank page. And the first thing that I notice on row 1 is that we have on the left hand side a term that is close but not quite what I would say symmetrical, where we have two x's but only one 3 contained within the term. Now my goal was to achieve a little bit higher level of symmetry, and in order to do that, let's just add another 3 to the term. And the quickest, easiest, and most logical way to do that is to raise each side of the equation to the third power. So now we have x to the x cubed is equal to 729 cubed. Now here's where we want to take a look at and remember some of the interesting and basic rules for exponents, where we have x to the y to the z is the same as x to the y times z is the same as x to the z times y. In other words, since multiplication is commutative, the orders of the exponents doesn't matter and is interchangeable. Now with that said, it may be clear what we can do in order to obtain a little bit more symmetry on the left hand side. And yep, all we had to do was take one of those 3's and smash it between the x. So now we have x cubed to the x cubed is equal to 729 cubed. Now this is a much more simplified and easier form to deal with. And the next step, which may be optional, but I like to do it for, just make things a little bit more simpler and easier to look at, is to rewrite x to the cubed as y. So now we have y to the y is equal to 729 cubed. So in other words, we have an unknown quantity raised to itself is equal to 729 cubed. Now, what's interesting about 729 is if you're like me and you memorized a good amount of your squares and your cubes and your square roots and your cube roots, you may know or recall that 729 is equal to 9 cubed. So that allows us to write the equation y to the y equals 9 cubed times 3. And once again, looking at our rules of exponents, we can simply just multiply, and now we have y to the y is equal to 9 raised to the power of 9. So we have an unknown quantity raised to itself equals a known quantity raised to itself. And from there, I think it's pretty easy to intuit and derive that therefore y equals 9, and therefore plugging x cubed back in, we have that x cubed equals 9. And then finishing out and solving for x, we get that x is equal to the cube root of 9, which should be our final solution. Now we want to go ahead and double check our work, and let's go ahead and do that right now. So once again, at the top left, I have just rewritten our equation, and on the right, top 2 rows, I have just rewritten our solution in 2 different formats. The first format that I want to take advantage of is the fact that x cubed equals 9. So you'll notice on the left-hand side of the original equation, we have an x cubed term. So all we have to do is substitute 9 for x cubed, and we arrive at x to the 9th equals 729. Next, we have our x term solved for, the cube root of 9. So we're going to plug that into x on the left-hand side. And in this case, we're just going to rewrite the cube root of 9 as 9 to the 1/3. And that allows us then to more quickly and easily see and visualize our problem. So we have 9 to the 1/3 to the 9th. And once again, remembering our exponentiation rules, we can multiply the exponents of 9 times the exponent of 1/3 to arrive at 9 cubed is equal to 729. And then finishing out the arithmetic, we have 729 equals 729. So the solution that we came up with of x being equal to the cube root of 9 is valid. This was a fun one. It showcases and allows us to take advantage of and exploit the rules of exponentiation, so to speak. And I hope you got the same answer, and I hope you come and check out another one of our videos.